students. Today we are going to learn about op-amp fundamentals. This is the very first topic of our subject. Our subject is linear integrated circuit and designing. So, in that first very important topic is the operational amplifier. So, in short it is also known as op-amp. So, first chapter regarding this is op-amp fundamentals. So, what is op-amp? Op-amp is a direct coupled high gain amplifier and usually consisting of one or more differential amplifiers and usually followed by the level translators and then output stage. So, in operational amplifier we have differential amplifiers. It is the combination of differential amplifiers and then it is followed by the voltage follower and then complete circuit will become or acts like a operational amplifier. So, if we see the symbol of op-amp, in short op-amp can be drawn like this. So, it is triangle like shape and these are the two inputs. So, first is inverting input and second is non-inverting input. At this output is there, then your op-amp is working on dual power supply. So, here plus VCC and minus VEE. Okay. So, in short this is the symbol of operational amplifier which is also known as op-amp. So, this is symbol, but inside this op-amp which components are present, which blocks are present, we will see that first and then we will go for the next topic. So, first point in this chapter is block diagram of op-amp. Block diagram of op-amp. So, in that block diagram, as I told you, it is multi-stage amplifier. There are total 4 blocks. So, in that first block is your input stage. It is having 2 inputs, one is inverting input, another is non-inverting input. Then at the output of input stage means first block, there is another step which is known as intermediate state. Intermediate stage. Then next block is level shifting stage. Level shifting stage. Then output stage. Then output stage and then finally your output of op-amp. So, overall op-amp is the combination of different circuits which are known as differential amplifiers, level shifting stage and then push pull amplifier. So, in this first stage contains which circuit? That is dual input, balanced output, differential amplifier. Differential amplifier you have learned in the second year in EDC subject. Then it is having 2 inputs, 2 outputs. That's why it is called as a dual input balanced. Input output are same. That's why it is known as balanced output. Then in intermediate state 2 inputs are there and 1 output is there. So, this is unbalanced stage. So, this block is also known as dual input unbalanced output. Which circuit? Differential amplifier. This is also differential amplifier. Then level shifting stage. Level shifting stage contains which circuit? That is emitter follower circuit, using constant current source, and output stage. Output stage contains complementary symmetry push pull amplifier, complementary symmetry push pull amplifier. So what are the uses of these blocks? First is input stage, differential amplifier. As we know, differential amplifier means it amplifies the difference between the two inputs. That means differential amplifier. So there are two inputs, there may be two outputs. So dual input, balanced output. There may be two inputs, one output. So dual input, unbalanced output. There are four combinations of this circuit. So in input stage, two inputs are there, inverting input and non-inverting input. This stage generally provides the voltage gain of amplifier. Op-amp is a high gain amplifier circuit. So for small input, it will give you very high output. That means your circuit is having very high gain. So here this stage generally provides most of the voltage gain of amplifier and also establishes input resistance of op-amp. It also possesses high CMRR, that is common mode rejection ratio, and this helps to reduce the noise at the output. Then second stage, CMRR term, you have learned about this in the second year also. Common mode rejection ratio. CMRR is nothing but it is the ratio of AD by AC, that is common AD by AC, that means differential gain divided by common mode gain. So we are rejecting the common signal, that means we are rejecting the noise. Second stage is intermediate stage, which contains unbalanced output differential amplifier. It is a dual input and balanced stage. So because direct coupling is used, the DC voltage at the output of intermediate stage is well above the ground potential. This stage again helpful to reduce noise and reduces the effect of temperature. So second stage is very much important for avoiding the effects of temperature, then change in supply voltage and aging. Then third stage is nothing but the level shifting stage. In that we are using emitter follower stage, emitter follow circuit. That means it follows whatever present at emitter side, it will give the same output. So it only shift the level, as there are direct coupling from first block to second block, then from second block to third block. So direct coupling is there. So because of that, your level of signal, DC signal, will get shifted. So we have to make it 0. So for making it 0, we require level shifting stage, where we are using the emitter follower circuit or DC level shifter circuit. Then last will be the output stage. This is the final stage and is usually a push pull complementary amplifier output stage. The output stage increases the output voltage swing and raises the current supplying capability of the op-amp. So this is the main function of output stage, that it will increases the output voltage swing and raises the current supplying capability of op-amp. So a well designed output stage provides low output resistance and high power gain. So overall, op-amp is nothing but the combination of these four blocks. So, this is the main structure. So, there may be question in your exam that write a short note on block diagram of op-amp. So, in the block diagram you have to write down all these things, you have to draw this diagram first and explain each block in detail. So, this is about the block diagram of op-amp. Yes. Now, next point is schematic symbol of op-amp. As I told you in the first point, that symbol of op-amp. So, in the symbol of op-amp there is same diagram I am drawing again. This is minus plus symbol. So, there are two inputs, suppose this is V1, this is V2, then this is output VO, and this V1 is plus symbol. Plus symbol means non-inverting input, and V2 means inverting input. Okay. So, all these voltages are measured with respect to ground. So, if we write A here, A means gain of this op-amp, large signal voltage gain or difference voltage gain of the amplifier. So, if we write difference voltage gain of amplifier, then Vd is equal to V1 minus V2. We can write like this. Then VO, that means output, is equal to V1 minus V2 into 80. We can write like this also, that means output upon difference between the input voltage is nothing but the voltage gain of op-amp. So, VO upon V1 minus V2. And main thing always you have to draw, that is its dual power supply. This is plus VCC, this is plus VCC, and this is minus VE. Always when you draw this diagram or a symbol, you have to draw this first, plus VCC and minus VCC. Yes. Now, how this op-amp practically present? So, it is in the form of IC. IC means what? Integrated circuit. IC means integrated circuit. So, this combination of all circuits like differential amplifiers, then level shifting stage, then complementary push-pull amplifier, then dual power supply. So, all are combined and form one integrated circuit or IC, which is known as op-amp IC. So, practically its number can be IC 741. It is one of the op-amp which is manufactured by the which is manufactured by many companies. So, we will see which companies are there, like Motorola, National Semiconductor, then Texas, Signetics, like that. These companies manufacture these ICs. So, it is draw like this, and it is 8 pin IC. So, there are 8 pins for this op-amp IC. So, here you can write like this, here you can write IC 741. Then which pins are present? First is the offset null. Second pin is inverting input. Pin number 3. Pin number 3 is non-inverting input, and pin number 4 is minus VEE, dual power supply, different second connection, that is minus VEE. Then pin number 5 is again offset null, then pin number 6 is output, pin number 7 is plus VCC, and pin number 8 is not connected anywhere, it is free. So, plus VCC minus VCC, that means pin number 7, pin number 4, output is pin number 6, then offset null is pin number 1 and pin number 5, and 2 and 3 will be the inputs in non-inverting input and inverting input. So, your op-amp IC, which is 8 pin IC, is given like this. So, there are different packages for these ICs like flat pack package, metal can package, dual inline package. So, generally practically we are using dual inline package. So, dual inline package is like a black structure, it is like a black structure. In lab it is available for practicals. So, I am drawing here, but it can be somewhat like this. So, this is structure of your pins. So, these pins are there. So, this black structure is there, and this IC we are using on the breadboard and then use for the practicals. So, this package is known as dual inline package. Then it can be flat pack package, it can be metal can package. Metal can package is nothing but the transistor like structure where 8 pins are there, okay. But practically dual inline package is generally used. Then IC 741 can be written as LM, first LM. So, this is the symbol, LM is the notation for companies. So, National Semiconductor will National Semiconductor is manufacturing this IC 741, it is denoted by LM. If it is done by Motorola company, then it is MC 1741. Then Texas SN 32741, and if it is Signetics, then it is N5741. Like this numbers are there. So, there may be any number, and from that you should come to know which company is there. So, flat package is more reliable and lighter than DIP package, and it is used for airborne applications. So, this is DIP package. DIP package is the best choice for using IC, op-amp experimentation and breadboarding purposes. It is easy to mount, it is which does not bend, or there is no soldering of leads. It is also suitable for mounting on PCBs because of its lead constructions, and more spacing between the leads is there. So, for at relative high power and dissipation of unreliable heat, base package is the metal can package. It is also 8 pin metal can package, okay. So, for practically we are using DIP, and for PCB connections also we can use DIP. So, this is the pin configuration of IC 741 op-amp, and this is the end of introduction of op-amp. We will see the next point in the next lecture. Thank you.